We'll see about the coal. So what is a coal and what is the analysis of the coal? That there are to identify whether the coal properties, the two analysis can give complete picture of the coal. That is proximate analysis and ultimate analysis. Okay. So first we'll go through the coal. So we know that important solid fuel. Coal is an important solid fuel formed as a result of alteration of vegetable matter under some favorable conditions by action of heat and pressure over a million of years. Right. Coal is mainly composed of carbon, oxygen, hydrogen, and nitrogen. So mainly the coal, the major composition of the coal contains the carbon, oxygen, hydrogen, and nitrogen. So majority, if you take the composition of coal is 100%. If you in that 100%, most of the 80% will be carbon, and 10% or 10 to 15% will be the hydrogen, and the remaining 10% will be the oxygen and nitrogen. We know that nitrogen is non-combustible gas, and also we know that nitrogen is non-combustible gas, and hydrogen is a combustible gas, and carbon is a combustible material, and oxygen will help for the combustion of the coal, but it does not give any calorific value of the fuel. Okay, so we'll see what is a so if any carbon, if you take any coal, if the more percentage of carbon is there, means 90% of carbon is there, means that is a very pure coal. If any carbon, if you take that carbon 90% or 95% of the carbon is there, means that is a very good coal, means impurities are very less. And if any coal, if you take percentage of nitrogen is more, in the coal sample, means that is a impure carbon, because nitrogen does not give any calorific value to the coal, so that nitrogen will be regarded as impurities for the coal. Okay, so to analyze what is the composition, of this coal, there are two analyses are there, that is proximate analysis and ultimate analysis. So we'll see what is proximate analysis, what is ultimate analysis. So what is this analysis? This analysis will give the complete picture of the coal. Okay, so this is the one of the image of the coal. So coal means, you might be thinking that is a coal which we have seen in a daily life. So coal is a richest form, and this coal is also called as there are different types of coal will be there: anthracite coal and bituminous carbon. So the coal which we see in our daily life, that is a bituminous carbon or bituminous coal. This the in the image which you are seeing is also called as anthracite coal, or the richest form of the coal, and which will have the high calorific value of the coal. And sometimes this coal may be in the form of a graphite. Okay, so if you compare to the normal coal, this coal will be very high calorific value. So whenever we are talking about the coal, so if the calorific value of the coal is high, means that coal is a very good quality of coal. Okay, so we'll see. This is a procedure. So the question may be asked like in this way: write the procedure for the proximate analysis. So in the proximate analysis, there are two types of questions they may ask. The first one, they will ask, write the procedure, means write the procedure how you analyze the proximate analysis of the coal. And another question, write the advantages or the significance of the proximate analysis, right? So the question, and also sometimes they may ask the combination of the both. Write the procedure of the proximate analysis and write the significance of the proximate analysis. First, we'll see what is a proximate analysis. So it involves the determination of the percentage of moisture, volatile matter, ash content, fixed carbon in a coal is called proximate analysis. If anybody says what is a proximate analysis, means if we analyze If we analyze moisture content, volatile content, ash content, fixed carbon in a coal, this whole procedure is called proximate analysis. So proximate analysis gives the percentage of moisture in a coal, volatile matter in a coal, ash content in a coal, fixed carbon present in a coal. So proximate analysis will give all these contents. Suppose proximate analysis means the proximate analysis is also called as physical analysis, physical structure of the analysis. And this is also called as physical analysis of the coal sample. Means the moisture content. You know that what is a moisture content? Moisture content means percentage of water present in a coal. Moisture content means percentage of moisture present in a coal. Volatile matter means what is a volatile matter or the volatile substances? The volatile matter or the volatile substances are the substances which easily convert into gas. What is a volatile substances? Volatile substances are the substances which at room temperature it can be converted into gas phase, or at a room temperature this can be converted into gas. That is called volatile matter. Means volatile. It will be volatile at a easy temperature, at a low temperature. The substances which are converting into gas phase or converting into volatile matter at a room temperature is called volatile matter. So generally these volatile matter are called organic substances or organic matter. Okay, so organic matter. And next one, when we are coming for the ash content, third one is ash content. What is the ash content? Ash content is nothing but the percentage of inorganic material present in the coal, or the ash is nothing but inorganic substances like minerals like iron, copper, manganese, right? And also percentage of nitrogen present in the sample, or the uncombustible material present in the coal is called ash content, right? So ash content means once all the combustible material is combusted, the remaining part of the coal sample is called ash content, right? So fourth one, fixed carbon in a coal. So fixed carbon in a coal is nothing but, fixed carbon means the how much amount of the carbon actually, how much amount of carbon is present in a coal, that will give this is actually which we require the actual content in the coal sample. So this moisture will be the impurity, volatile matter will be the impurity, ash will be the impurity. Actually this is our important, and this is our required material in the coal. If you consider any sample, if we go through the proximate analysis, if the fixed carbon percentage is about 99%, that coal is 100% pure sample, or that coal is 100% better coal. Or if the moisture content, volatile matter and ash content is a high percentage in any coal sample, that is a not good quality of a coal, right? So this proximate analysis, I hope everybody is understand about the proximate analysis. Proximate analysis is nothing but identification or the analysis of moisture content, volatile matter, ash content, and fixed carbon present in a sample is called proximate analysis, right? Proximate analysis of a coal. Proximate analysis is also called as physical analysis. Proximate analysis is also called as physical analysis. Why it is called physical analysis? Because we are not going to characterize any chemical characteristics of the coal. You know that percentage of moisture is a physical nature, volatile matter is also physical nature, ash content is also physical nature, carbon is also physical. Just we are not doing any chemical reactions here. Just we are analyzing the physical properties of the coal. And that's why the determination of the physical properties is also called as proximate analysis. Okay. So I hope everybody is understand, students. So next we'll go through the procedure, means how we'll do the moisture content, how we'll do the volatile matter, how will procedure means laboratory procedure, how we'll do the ash content, how we'll do the fixed carbon content. Okay. Right. So this is moisture content. About 1 gram. So we'll see first what is a moisture content. Okay. About 1 gram of powdered air-dried coal is sample. Air-dried coal sample is taken in a crucible. So this is a crucible. Students, so this which we are seeing on the screen, right side up, this is a crucible, is taken and heated at 100 to 105 degrees centigrade in an electrical hot air oven for 1 hour. The loss in weight of the sample is found out, and the percentage of moisture is calculated as percentage of moisture in coal is equal to loss in weight of the coal by weight of the coal sample taken into 100. Okay. What is the percentage of moisture, and what is a crucible, and what is why we have to heat for 100 degrees centigrade to 105 degrees centigrade? So what is our aim? Our aim is to analyze the moisture content. Moisture content is nothing but percentage of water present in a coal sample. We know that boiling point of water is 100 degrees centigrade. So if we heat any substance above 100 degrees centigrade, the moisture will be removed, right? The moisture will be removed. So the removing percentage of the moisture can be analyzed by taking before heating weight W1, after heating W2 weight. So that will give the loss in weight of coal. Loss in weight of coal means first we'll take the 1 gram of sample. Then we'll weight that, and we'll take the weight of that sample. How much we'll get? Suppose if you take 1 gram of sample, then you keep in a hot air oven by keeping 100 to 105 degrees centigrade for 1 hour. 1 hour. Suppose that will note down as a W1. Then after 1 hour, if you maintain for 100 to 105 degrees centigrade, then if you after 1 hour, if you take the W2, suppose if the W2 weight is 0.8 grams. 0.8 grams means that 0.8 grams means 0.2 grams is the percentage of moisture. 0.2 is a percentage of moisture. So loss in weight of the coal. Loss in weight of the coal here means here 0.2. 0.2 by weight of the coal sample taken means this is a 1 gram to 100. So you'll get the percentage of moisture. Okay. Okay, students, in this way we'll calculate the percentage of the moisture. Okay. First we'll take the 1 gram of coal sample. Then we'll take the weight 1 gram of coal sample, that is a W1. Then after that, the 1 gram of coal sample is kept in a hot air oven by maintaining 100 to 105 degrees centigrade for 1 hour. Then after 1 hour, you take from the hot air oven and you weight that is a W2. If the weight of that one will decreases, means if it is a 0.8, means how much loss in weight of the coal is 0.2. So you'll note down here 0.2, and the weight of the coal sample is a 1 and into 10. So if it is a 0.2 means the percentage of the moisture is 20%. So like that, we'll calculate. Okay. Students, so like that, we'll calculate here. Like that, we'll calculate the percentage of moisture. In this way, the percentage of moisture will be calculated. Then we'll come to the how we'll analyze. So we have seen these images. So what is these images means? These images are called desiccator. So what is this desiccator means? This is a closed system. Actually, we does not require, but anyway, here it is there. No, I'll try to explain this one. So desiccator means desiccator which contains some anhydrous CaCl2. Anhydrous CaCl2 means anhydrous CaCl2 calcium chloride. Always calcium chloride if we added to any substances that will absorb moisture percentage from the water, moisture percentage from the substance. So if you keep this for 5 minutes or 10 minutes, if any moisture percent is there, that will be absorbed. Okay, that is the use of the CaCl2. CaCl, this will call as a desiccator. So generally this will be used in a high research laboratories, but right now it does not require anything that much relevant to this subject. Okay, next we'll see volatile matter. So what is a volatile matter? Volatile matter is nothing but the substance which easily convert into vapor state at a room temperature or at lower temperature. Okay. After the analysis of moisture content, means in the first step, we have analyzed the moisture content. After the analysis of moisture content, the silica crucible with residual coal sample is covered with a lid and is heated at 950 to 970 degrees centigrade for 7 minutes in a muffle furnace. So this is a volatile matter. So how to analyze the volatile matter? How to analyze the volatile matter means we have to take the sample. Sample means from which sample we have to take this sample. Already we have removed the water percentage. That sample we have to take. Means we have only now 0.8 grams. Okay. After the analysis of moisture content, the silica crucible with a residual coal sample is covered with a lid and heated at 950 to 970 degrees centigrade for 7 minutes in a muffle furnace. Then after the first volatile percentage completed, then you take the coal sample and you take in a muffle furnace. Muffle furnace is a furnace which can maintain up to 5000 degrees centigrade. Muffle furnace is a furnace which can heat any substance up to 5000 degrees centigrade. And silica is a crucible. Silica is one of the small dish like it is made up of a ceramic material. It is called a silica crucible. So silica crucible is one of the small bowl. So it is a looking. So the silica crucible maybe looks like this. Right? It is a small bowl. So which can withstand, right? So in this one, so they will add coal sample. So this is a silica crucible. So they will add a small amount of the carbon so that this silica crucible is made up of ceramic material which can withstand about 3000 degrees centigrade. So that's why, because we have to maintain the 950 to 970 degrees centigrade. So we have to take the coal sample in this one and we have to wait and we have to heat for 950 degrees centigrade to 970 degrees centigrade, so that, and also we should not kept this for more than 7 minutes. We have to keep for only 7 minutes. If you keep for 15 minutes, all carbon sample will be converted into ash. All sample will be converted into ash. But actually the coal melting point is only 700 degrees centigrade. But we should not keep for a more time. So we have to kept this coal sample at 950 to 970 degrees centigrade at 7 minutes, and quickly we have to remove. Actually, it is 5 minutes to 7 minutes. So after that, we have to quickly remove. Suppose if any volatile matter, means volatile matter is a matter which easily converts into gases. So if any volatile matter is there, that can be converted into gas phase. So the remaining percentage will be non-volatile matter. Okay. In a muffle furnace, the loss in weight of the sample is found out and percentage of the volatile matter is calculated as. So how the percentage of the volatile matter is calculated? Percentage of volatile matter in a coal is equal to loss in weight due to removal of volatile matter. Due to removal of volatile matter means we'll take the W1 weight of the coal sample before we are keeping in muffle furnace, and W2 is the weight of the weight of the coal sample after heating for 7 minutes. That's W2 minus W1 will give the loss in weight due to the removal of volatile matter. Means all the volatile matter will be converted into gas phase or escape into the environment at 950 to 970 degrees centigrade within 7 minutes. Then the remaining portion will be free from volatile matter. That the percentage can be calculated by loss in weight due to removal of volatile matter by weight of coal sample taken into 100 will give the percentage of volatile matter. Okay, students. So from this, we can understand what is the percentage of volatile matter. Okay. So now we'll see what is ash content. Okay. Ash content. Ash content is nothing but we have already discussed. What is the ash content? The remaining portion of the non-combustible material. Okay. After the analysis of volatile matter, the crucible with residual coal sample is heated without lid at 700 to 750 degrees centigrade for half an hour. In a muffle furnace. The loss in weight of the sample is found out and the percentage of ash content is calculated as. Percentage of the ash content is calculated as. Okay. What the ash content means? Now, in the third step, the same sample which we have kept in a first sample, in the first step, we have kept in a hot air oven for 1 hour. Then the same sample we have taken for 950 to 970 degrees centigrade. We have kept in a 7 minutes by holding the cap for 7 minutes. And the same sample, then we are brought to, we have to keep to 700 degrees centigrade, 700 to 750 degrees centigrade without opening the, by opening the cap for half an hour in a muffle furnace. Okay. So that means all the carbon. So generally the carbon. Okay, students. So now the time is up. Only 10 minutes is there. So we'll finish this content. Okay. So tomorrow we'll see the ultimate analysis. Okay. So once this 700, in the third step, we kept 700 to 750 degrees centigrade for half an hour in a muffle furnace in an open air. All generally the carbon will decompose at 700 to 750 degrees centigrade. 700 to 750 degrees centigrade. In this one, if hydrogen is present, carbon is present, any matter, all the carbon present in the coal sample will be combusted. All the carbon present in the sample will be combusted. The remaining will uncombustible material. Remaining only uncombustible material will be present in the sample. Okay. That's why we keep it for half an hour and we'll open, and any gases will be there that can be easily escaped. Okay. And half an hour furnace. Okay. The loss in weight of the sample is found and the percentage of ash content is calculated. It means what are the remaining portion? If we keep the coal sample for 700 to 750 degrees centigrade for half an hour by opening the cap, so whatever the content is remaining on the crucible, that will take the weight of the ash former. So percentage of ash content in a coal is equal to weight of the ash former by weight of the dry coal sample into 100. Okay. This will give the percentage of ash. Okay. Then we are coming for fixed carbon. So what is a fixed carbon? It is determined by subtracting the sum of the moisture content, volatile and ash content. What is the fixed carbon? Fixed carbon is equal to what is if you take the coal sample is 100% minus, if we consider this coal sample is 100%, and if you subtract the moisture content and the volatile content and the ash content, so the remaining will be your fixed carbon. Fixed carbon is actually required. So 100 minus, if you remove all the contents, so that is called a fixed carbon. Okay. So this is called our proximate analysis. In this way, we'll do the proximate analysis. So I will take attendance. Only 46 students are present. Let them. We does not have any force to attend all the people. Whatever